Hello everyone, this is Christian and you are welcome back to the DonHub channel. So in this video, we are going to talk about data so far as machine learning model is concerned. Okay, so we are also going to look at some forms of data and how our data can affect our model. So for this and more, kindly like this video, share it, click on the subscribe button, turn on your notification, and let's start. Alright, so when we say data basically mean collection of information. Okay, and this information we feed it to our model, then our model process it with algorithms and try and make predictions out of it. Okay, so data is very important, and when the data is not in the right form, I mean when your data contains inconsistency values, then it means your model will be learning the wrong thing, and definitely its performance will be bad, right? So in that case, we have to pre-process our data and make sure it's in the right form. During pre-processing, there's a lot of things we do consider, and we try to transform our data, we clean it and we organize it to make it suitable for analysis, okay, and for machine learning. So once you've pre-processed your data and you visualize it, you should be able to make some meanings or analysis out of it. And if you are not able to do that, it basically means your model won't be able to do, and which means your performance or your model's performance will be bad. So once you are done pre-processing, you should be able to make some analysis from your data, at least some analysis, right? And during pre-processing, we do some activities or we perform some activities, which includes cleaning. When we say clean, we are removing missing values and duplicates, okay? And we also perform transforming. Transforming here, we try to make sure the features or the columns have their right data types, and we scale the features, encode our categorical values, okay? So let me talk a bit about categories. So with this data we have here, data set we have here, our categorical values are these ones, and these values our algorithms, our models don't understand them, so we have to encode them to normal numerical values so that our model can understand. Okay, yeah. So we also talk about reducing size. When you see the size, the number of columns, okay, when it's very large, the high probability that the model will perform badly or poorly is also high. Okay, so you have to reduce the size and make sure you don't lose the important information. Okay, whilst you are reducing it, you have to keep it in mind that you don't lose the important information of your data. You have to also perform normalization on the data set, which ensures that all the features they are in the same scale, so that some features won't be dominant. In this case, looks more informative or more important than the others. You have to scale them within the same range. Okay. Now let's talk about data types. When we say data types, we have numerical data types and categorical. Okay. So with numerical, we have continuous and discrete data, and with categorical, we have nominal and ordinal. All right. So we talk a little bit about them when we are actually working on a data, okay, which is in our next video. But for now, just know that we encode the categorical data to a normal no, numerical data so that our model can understand them. We also have data visualization. Yes, data visualization. With data visualization, we have three types here. And the first one is the 2D. So it's based on how you want to view your data. Okay. So you want to use the 1D. You can use the bar chart, pie chart, or histogram. Okay. And as you can see here, we have bar chart, we have histogram here. And we also have 2D. With 2D, we have scatter plot. You can use heat map. And this image here is a heat map diagram, okay, of our data. And with the 2D, the 3D, we have a scatter plot here. We have our scatter matrix, and our bubble chart. And this one you are seeing here is a scatter matrix. Okay, so this one you are viewing your data from a 3D space. Okay, And with data visualization, you can be able to, at least it will give you some fair idea about the kind of algorithm you should use. Okay, so that is very, very important. And also, once you visualize your data, at least you should be able to make some meaning out of it, as I stated earlier on. If you are not able to do that, then there is some question mark when it comes to your preprocessing. Now, let's talk about the data transformation. Okay, so when we are transforming our data, we do a couple of things, as I made mention earlier on, handling our missing data. Okay, so when you look at your data, let's go to this data. Even though it's full, none of them is missing. Assuming this three was not there, the one thing you can do is delete the entire row. Okay, that is the first choice. And second is calculate the mean for this, and then you replace this empty with the mean. Okay, that is if you are assuming this three is not there, right? So these are the two basically ones. They have other ones too, whether you want to use KNN imputation and other stuff. But for now, just know that it's either you delete the rule or you calculate the mean or any value, constant value, and then replace the null values or the empty values with that. That is the empty, uh, the missing data with that. Okay. When you are making this decision, you have to consider a lot of things. One, your missing data really large? If there are too many, then try to go by using either main imputation, KNN imputation, constant imputation. We'll talk about them. But if they are just few, then you can just try and delete those rows. Okay. Now let's talk about encoding. So with encoding, you can use either label encoder or one hot encoding. Okay. And with this one, encoding, as I said earlier on, we perform that in our categorical dataset. So with this one, we can encode them into one hot encoding or label encoder. Okay. So now let's move on to feature scaling. Okay. So as I said earlier on, the goal is to bring your features within the same range. Okay. And you can use either standard scalar or standardized z-score, and we will talk about this much into details in our next video. And we also look at dimension reduction. We have to reduce the columns we have, okay, to make preprocessing faster and also increase the performance. And we have feature extraction. With feature extraction, what you do is you create new features from the original features you have, okay, and then you use those new features in your processing of your or training of your model. Okay. And with feature selection, what you do is you don't create new ones, but you eliminate the less informative columns. Okay, you remove those ones. And with feature engineering, what you do is it's almost the same as feature extraction, but with feature engineering, after creating the new columns, you don't dump or you don't eliminate the old columns. Okay, so you have your new columns with your old columns. Okay, so you have your old columns or your old features, you use that to create new features in addition to your old one. Okay, that is feature engineering. And from there we can now split our data into training and testing sets. Okay, so I hope this video you really enjoyed it, and in the next video we are actually going to do hands-on on this data. Okay, so I will prepare a data and you use that data to go through the entire process we've stated, so that you will get the practical overview. Okay, hope you really enjoyed this video. If you did, kindly click on the like button, share this video with friends, and see you in the next video.